Good morning, student. Let's start today's class. Today we are going to discuss about Internet. Okay, Ethernet. So the most widely used high-speed lane. Okay, high-speed lane network today are based on the Internet. Internet is a network uh, network type. Okay, so in Internet and were developed by the IEEE 802.3 standard committee. Okay, so the internet is developed by IEEE 802.3 standard committee. Okay, and it is used for high speed LAN networks today for today. Okay. Then in it the internet in internet, okay, random access method or contention method are used to send data. Okay, by this method the uh, data will be sent. Okay, which is a random access method. Okay, now what is random access method? It is a method where no station is assigned only no station is assigned any priority, that is no station is superior to another station. Okay, so here station means the points. Okay, let's say um, this is one station, this is one station, this is one station, this is one, this is one, then this is the connection. Okay, this is the network. Okay, so here no station give any priority. Okay, so anyone can send over anyone. Okay, let's say this one and this one. Okay, this one, let's say station 1 and station 2 want to send data at the same time. So there is, since there is no priority, randomly S1 can send first, S2 can send then, or S2 can send first and after then S1 can send. Okay, so there is no priority given to any uh, 1 minute, given to any station. Okay, and and so since there is no priority given to any station, the station no station is superior to another station. Okay, then this method is called random access method because there is no schedule time. Okay, no schedule time for station to transmit, and there is no rule specify which station should send next. Okay, so there is no specific time and there is no rule also that which station send first or and which station send next. Okay, so that's why it is called a random access. That means and the stations randomly accessed the uh, medium or the network or the link. Okay, then random access method is of two types. Okay, one is LOA LOA and LOA is it is used a very simple procedure called multiple access. Okay, MA. Okay, and LOA further of two types, pure LOA and slotted LOA. Okay, now the second one is CSMA. Okay, which is LOA is improved with the addition of a procedure that forces the station to sense the medium before transmitting. This is called sense multiple access, which is SMA, sense multiple access. Okay, that means in this sense multiple access, what happened, before sending any data, the station should sense the medium. Okay, that the medium is busy or free. Okay, then CSMA is further divided into two types. Okay, one is CSMA-CD and one is CSMA-CA. Okay, CSMA-CD and CSMA-CA. In your course, there is only there is CSMA-CD. Okay, and CSMA-CD full form what? Carrier sense multiple access with collision detection. Okay, carrier sense. Okay, carrier sense, then carrier sense access carrier sense multiple access with collision detection. Okay, then it is a method it is a method it is a modified version of CSMA. Okay, and it is a media access control method that was widely used in early internet ethernet technology. Okay, this method is only for used in early internet technology when there is used to be a shared bus topology. Okay, and each node were connected by coaxial cable. Okay, so at that time this technology or method is used. Okay, then nowadays internet is full duplex, and CSMA-CD is not used as a topology in either star or point to point. Okay, so in previously bus network used shared bus network used, and that shared bus topology we use CSM CD. Okay, but nowadays both topology is not used. But in internet full duplex is used. Full duplex communication is used, and star and point to point connection is used. So here CSM CD is not used. Okay, then consider a now let's see what is the function or what is the purpose of CSM CD. Okay, consider a scenario where there is a n station linked with all are waiting to transfer. That means let's say consider a link. Okay, there is, let's say a link is there. There is station 1, station 2, station 3, station 4, station 5, etc. Okay, now let's say 5 station, or let's say n station. Okay, connected to a network. Okay, now at the same moment all the station want to send data. Okay, at same time all the station want to send data through this medium. Okay, so at the time one problem is created, which is the collision of data. Okay, collision of data means, let's say this send data, and this S1 send data to S3. Okay, and at the same time S3 want to send the data to the S2 or S1. So that data from S1 and S3 collide each other at any point. Okay, at that time this collision problem is happened. Okay, and that collision problem is rectified by using SMCD SMA-CD. Okay, and SMA-CD is one such technique where different stations that follow this protocol agree on some terms and collision detection measure for effective transmission. Okay, so in SMA-CD the collision detection process will be happened, and this protocol decide which station will transmit when, so that uh, reach the station without reach the destination without uh, corruption. Okay, that means this topology decide which station which station transmit when, and no, it decide that which station transmit when when and uh, by that way the collision will be prevented. Okay, if there is a 5 number of stations, okay, and 5 number of stations transmit one by one, okay, one another one or one after one, then the collision will be sorry, the collision will be collision will be not happened. Okay, so this work is done by the CSM CD. Okay, now let us see the working or the function of CSM CD. Okay, then check first what happened. First check if the sender is ready for transmitting data packets. Okay, then check if the transmission line is ideal. Transmission line is ideal means it check whether the transmission line is free or collision happened. Okay, that how this check is done by sending a demo signal to the destination. Okay, let's say here, let's say this is S1 and S2. Okay, so there is whenever CSM CD check the transmission line link is ideal or not, this she send, or it send a demo a demo signal to destination, and if the demo signal is received at destination after some time, then it will then it uh, consider that the line is free. Okay, and or line is ideal. Okay, then transmit the data and check for collision. Okay, then after transmitting data or actual data to the destination and check whether at the time collision happened or not. Okay, if no collision were detected, it propagation okay in propagation the sender completes its frame transmission and re- reset the counter. Okay, so if collision is happened, then the process of the collision removing is done, but if there is no collision happened, then then all the information transmitted to the receiver end. Okay, now let us see how a station know if its data collides. Okay, this is the purpose. The station, how the station know that the data which is collide is is itself. Okay, oh, sorry, is sended by itself. Okay, so uh, that means if a collide happened here, okay, that collide data or that collide data, how this station know that that collide data is himself or it is his. Okay, his data. Okay, so to ensure that by using to ensure by how technique or which technique, let us see. Okay, consider two station A and B. This is A, okay, and this is B. Okay, and propagation time is TP. Propagation time means the data sent from A to B or reach from A to B in 1 hour. Okay, then at the time of 0, okay, at A transmit it data. Okay, at the time of 0, A transmit it data. Okay, then at time 30 uh, the collision occurs. Okay, here this collision will occur. Collision will occur at time t 30 second. That means after 30 second, sorry, 30 minute, after 30 minute of transmitting data from station A, the collision will happen. Okay, and after collision, a collision signal is generated and sent to both A and B to inform about the collision. Okay, the collision, two collision signal, or one collision signal is generated here in the collision place and sent to both A and B. Okay, and since the collision happened in midway, the collision signal also take 30 minutes to reach AB. Okay, let this signal from A to collision end takes 30 minutes, and when the signal is generated here, collision signal is generated here and sent to the station, that signal is also taking 30 minutes to reach the station. Okay, so total, therefore t equal to 1 hour and AB receive the collision signal. That means the A or B receive the collision signal after 1 hour. Okay, whenever the collision is happened in the midway, then after 1 hour the collision signal is received by station A. Okay, so so now how to ensure that the collision data is our station data. Okay, so for this transmission time, okay, and is greater than propagation time. Okay, transmission time means that the signal going to the collide place, and from the collide signal reach to the station, this total time is called transmission time. Okay, so transmission time should uh, greater than the propagation time. Okay, so when this is because we want that before we transmitting the last bit of our data from our station. Okay, we should sorry, we should at least be sure that some of the data, some of the bit have already reached to the destination. Okay, that ensure that the the link is not busy and collision will be not occur. Okay, sorry, transmission time is, I'll tell you wrong. Okay, sorry, transmission time is, see, let's say this is two stations. Okay, this is S1 and this is S2. Here the data 10110 to the end. The propagation time means, let's say first bit, the first bit going to from S1 to S2, the time taking is called propagation time, which is TP. Okay, but to transmit all the bit one by one, okay, that time taking by that or time taking for transmitting all the bit of the frame is called transmission time. Okay, which is TT. Okay, and this TT is always greater than to TP. Okay, and or should be greater than to TP. Okay, because before sending the last bit, let's say this one is last bit. Okay, before sending the last bit, we the station one should ensure ensure that some of the bit is received at the receiver end. Okay, so let's say 1 0, then 1, then 0, then 1. Okay, this is the total transmission time. This is the transmission time to send that 1 2 3 4 bit. Okay, let's say TT equal to 2 hour. Okay, and which is greater than the TP here, TP is 1 hour. Okay, so after 1 hour, okay, we receive collision uh, collision signal, or the acknowledgement signal, or the acknowledge about the receiver, about the receiving of data. Okay, so after that, after receiving that acknowledgement, the sender ensure that some of the data will be received at the receiver. So uh, that ensure or receiver sorry, sender ensure that after that which collide signal is coming, that is the collide signal of that data. Okay, so the transmission time should be greater than the propagation time. Okay, That's all about your internet and CSM CD. Okay, thank you.